Okay, good morning, everybody. We are going to take a look at the Chapter 12 review here. The first section we are evaluating using the unit circle. So cosine of 2 pi over 3. 2 pi over 3 is right here. Cosine of this angle, the x-coordinate, negative 1/2. Sine of negative 240 degrees. So negative 90, negative 180, negative 270. So negative 270, but we need 30 degrees less than that, right? So negative 270, negative 240, it would be right here. So negative 180, negative 240, another 60 degrees. So sine the y-coordinate, square root 3 over 2. Tangent of 3 pi over 4. So 3 pi over 4 is right here. The tangent of this, well, these have the same xy coordinate, so tangent is y over x. So this one divided by this one, they're the same, so it's going to be 1. This one's negative, so it's going to be negative 1. Cosine of 300 degrees. So 300 degrees right here, cosine of that is 1/2. Tangent of 13 pi over 3. Now, I don't see 13 pi over 3 on the unit circle, which is a good indication that this is larger than 2 pi. And it definitely is larger than 2 pi. So it's more than one full rotation. So let me convert this to degrees by multiplying by 180 over pi. Okay, so I got 13 times 180 divided by 3. So this is 780 degrees. All right, much more than 360. So if we subtract 360 from that, we get 420, which is still larger than 360. So we need to subtract 360 again. And we get 60 degrees. So this is equivalent to a 60-degree angle. So we're looking for tangent of 60 degrees. So 60 degrees is here. Tangent is the y over the x. So we have square root 3 over 2 over the x, 1/2. So we have to change this to multiplication. Square root 3 over 2 multiplied by 2 over 1. These cancel, so it's just the square root of 3. So tangent of 13 pi over 3 is the square root of 3. Sine of 720 degrees. So 720 is much more than 360. It's actually a multiple of 360, which means that it's this point right here. Okay, because 360, 720. So it's right here. Sine of this is going to be the y-coordinate, so sine of 720 degrees is 0. Which of the following are equivalent to an angle with measure pi over 6 radians? Okay, so let's take a look at pi over 6. Pi over 6 in degrees. Well, actually, we need to go through all of these and just see if they're equivalent to pi over 6 radians. Let's start with 30 degrees. So 30 degrees over 1 multiplied by pi over 180. So 30 over 180. I gotta get a calculator that will do fractions. So 30 over 180 is 1 over 6. So 30 degrees is a pi over 6 angle. So this one is correct. Now let's take a look at negative 270. Negative 270 is so negative 270, negative 90, negative 180, negative 270. Negative 270 is a pi over 2 angle. So that is not correct. Negative 11 pi over 6. So pi over 6, this is a 30-degree angle. So we can check these comparing it to either this or this. So negative 11 pi over 6. Let's multiply this by 180 over pi to get the degree measurement. So 11 times 180. 11 times 180 divided by 6. So this is a negative 330 degree angle. Now a negative 330 degree angle is the same as a 30 degree angle. If we look at the unit circle, negative 90, negative 180, negative 270, negative 360, so negative 330 would be right here, which is indeed a 30 degree angle. So this one is equivalent to pi over 6. 13 pi over 6, okay? So 180 over pi, 13 times 180 divided by 6. This is a 390 degrees. 390 degree angle, which if we subtract 360 from that, because it's one full rotation, this is also a 30 degree angle. So both C and D. Go to E. 410, so that's greater than 360. Let's subtract 360. That's a 50 degree angle. That is not correct. Negative pi over 2. Multiply this by 180 over pi, and we get that this is a negative 90 degree angle, which if we look at a negative 90 degree angle, we see that that is actually 3 pi over 2, or a 270 degree angle, which is not the same. Negative 60, so a negative 60 degree angle would be 30, so negative 30, negative 45, negative 60 would be a 300 degree angle, which is not correct. And a 750 degree angle, let's subtract 360 from this a few times. So subtract it once, you get 390. Subtract it again, you get 30. This is a 30 degree angle, so this one is also equivalent to pi over 6. So A, C, D, and H were all equivalent to pi over 6. Approximately how many degrees are in 1 radian? Okay, so what we need to remember here is that there are 2 pi radians in 360 degrees. So we can solve this for 1 radian by dividing by 2 pi. So we get 1 radian is the equivalent of, so let's do 360 divided by 2 pi. (360) divided by 2 pi is about 57.3 degrees. So 1 radian is approximately 57.3 degrees. Which of the following are equivalent to sine of 2 pi over 3? So first let's figure out what sine of 2 pi over 3 is. So 2 pi over 3 right here, the sine of that is square root 3 over 2. So we're looking for the ones here that are equivalent to square root 3 over 2. So sine pi over 3. Sine pi over 3 is square root 3 over 2. So A works. B, cosine of negative pi over 6. Okay, so pi over 6 is a 30 degree angle. So negative pi over 6 is down here, a 330 degree angle. And which one are we looking at here? Cosine, so we're looking for the x-coordinate. So the x-coordinate of the 330 degree angle here is the square root of 3 over 2. So this one is also the same. Tangent of 7 pi over 6. Okay, so let's look at 7 pi over 6. 7 pi over 6 is right here. The tangent of this angle would be the y-coordinate over the x-coordinate, so negative 1/2 over negative square root 3 over 2. I can already tell you this is probably not going to be the same, but we'll see. It actually might be the same. So we got negative 1/2 multiplied by 2 over square root 3. 2's cancel. Negative 1 over square root 3. Multiply by square root 3 to get rid of the radical in the denominator. Oh wait, these were both negative, so this is actually going to be positive because these are both negative. So we get positive square root 3 over 3, which is not the same. It's close, but it's not the same. So letter C does not work here. Cosine of 3 pi over 2. Okay, so 3 pi over 2 is right here. Cosine of 3 pi over 2 is the x-coordinate. It's 0, which is not what we're looking for here. Whoops. So that one does not work. So it's just A and B. Given the function 5 cosine of 2x, determine the following: the amplitude, period, y-intercept, and the frequency. So this has an amplitude of 5. We know the amplitude is equal to the A value, so the amplitude is 5. The period is 2 pi divided by the B value, which the B value here is 2. So 2 pi divided by 2, so the period is pi. The y-intercept, so with a cosine function, the cosine function starts at the maximum, the amplitude. So the y-intercept is actually going to be 5, 0, 5. The frequency is the inverse of the period. So if we have the period being pi, and the frequency would be the inverse, 1 over pi, or we could say that the frequency is b divided by 2 pi, so 2 divided by 2 pi, which is once again 1 over pi. So the frequency, 1 over pi. What is the maximum value of the function? So this is a sine function. The amplitude is 2. And it has a vertical shift by 5. So basically it's going to be up here at 5, and it's going to be oscillating with a amplitude of 2. So it's going to be going up to 7 and down to 3, back and forth, like this, starting at 5 because it's a sine function. So the maximum is going to be at 7. All right, and it's going to keep oscillating between 3 and 7 around the midline. This will give you what's called the midline, which is where it oscillates. 12. The standard middle C note in a musical scale has a frequency of 256 Hertz, or 256 cycles per second. Assuming an amplitude of 1, write an equation that models the displacement of the sound wave over time. So we're going to use a cosine function to do this because it's probably, most sound waves, you don't really start it at the maximum. You start it at the midline, like this. So we're just going to use a sine wave to do this. So we will call this S of t, or whatever you want to call it. Now the amplitude is 1, so the A value is going to be 1. The only thing we need to figure out here is the B value in front of the input t. So that would be the B value. So what we need to do is we have B over 2 pi is the frequency. Okay, 2 pi over B is the period. B over 2 pi, the inverse, is the frequency, and this is equal to 256. 256 cycles per second. So we'll multiply by 2 pi to solve for the B value, and we get B is equal to 256 times 2, which is 512 pi. So our function would be sine of 512 pi t. An object attached to a spring oscillates around a stable position according to the position formula, where t is in seconds and s of t is in feet. What are the period, frequency, and maximum displacement from the stable position. Okay, so if we picture what this looks like, it's a sine function, amplitude of 8, and its midline has not been changed because it doesn't, so midline of 0. So basically, this is going to be going up and down like this around 0, going up to 8 and down to -8. So the amplitude, does it ask for that? It says maximum displacement from the stable position, which is the amplitude. So the maximum displacement is going to be 8. That's the amplitude. The period is 2 pi over b. So in this case, 2 pi over 3, because 3 is the b value. So it takes, to complete one whole cycle, it takes 2 pi over 3, whatever, seconds or whatever. Yeah, I guess it's seconds because it says t is in seconds. So this 2 pi over 3 is approximately 2 seconds. Okay, it's about 2 seconds. The frequency, the number of cycles it completes in a single second, we would do the inverse. So instead of 2 pi over 3, it's 3 over 2 pi. So 3 divided by 2 pi. So about 0.477 oscillations or cycles per second. Okay, so almost half a cycle per second, and that should make sense because the period is 2 seconds. Well, wait a minute. Does that make sense? 3 over 2 pi, 2 pi over 3. So it makes one whole oscillation in 2 seconds. Which means that it's making half of a cycle in 1 second. Yeah, okay, that makes sense. So in 2 seconds, it would make a full cycle. A little bit more than 2 seconds, it'll make a full cycle. Okay. All right. Number 14. When you board a Ferris wheel, your feet are 1 foot off the ground. At the highest point of the ride, your feet are 99 feet off the ground. Okay, so the lowest point is 1. The highest point is 99. It takes 30 seconds for the ride to complete 1 full revolution. So the period here is 30 seconds. Write a trig equation for the height above the ground at t seconds after the ride starts. Okay, so we need to figure out where the midline is, where this is oscillating around. Okay, so 99 minus 1. So, yeah, we need to figure out where this is oscillating around here. And one way to see where this is oscillating around is to take the average of these. Okay, the average of two numbers will give you its midpoint. Essentially, we're looking for the midpoint of 99 and 1. So we'll add them together and divide by 2, which gives us that the midpoint here is 50. So we have a vertical transformation of 50. We have a vertical transformation of 50 here. All right, so what do we want to do here? Okay, yeah, so essentially what's happening, and you start at the bottom. Remember, on a Ferris wheel, you start at the bottom. So we'll start down here. We're going up here, coming back down, kind of like that. Okay, and then it repeats itself, kind of like this. The period is 30 seconds. The vertical transformation is 50. and we need to find the b value. So remember the b value, the period, 30 seconds, is equal to 2 pi over the b value. Okay, so if we solve this for b, we get b is equal to 2 pi over 30. All right, so what we have so far, and I'm going to have to use this room down here for problem number 15. So what we have so far is that our a value, our amplitude, is 49 because the distance from 50 to 99 and from 50 to 1 is 49. Our b value is 2 pi over 30. Our k value, our vertical transformation, is going to be 50. However, we also have a horizontal transformation as well. This is a difficult problem because it has a lot of these things. This also has a horizontal transformation as well because we don't have a function that starts at the bottom, okay? There is no function that starts at the bottom. A sine wave starts in the middle and a cosine wave starts at the top. Now we can think of this as being a cosine wave that's been shifted because the top is right here. So it's been shifted about a quarter of a period to the right. Or to the left, I mean. Or yeah, to the right. So we can think of this as just a regular cosine wave that's been shifted to the right by this amount, whatever this amount is. Okay, so what I need to do is I need to figure out how much this has been shifted to the right. And this is a quarter of a period. Okay, so I just need to take the period and divide it by, no, we have to divide the period by 2 because this is a shift, it goes, so this is the period right here. Okay, I drew it a little bit too far, but this is the period, this is where it starts repeating itself. Okay, so we need to figure out how much further this has been shifted over to the right. We need to divide the period by 2, and the period is 30 seconds. So this has been shifted to the right by 15 seconds. So our function, so that means our h value is 15. So our function is going to look like this. This was a relatively complicated one. Remember, this is a cosine function because it starts at the top technically after the shift. So our function is going to look like this. We'll call it h of t. We have a, our amplitude, which remember, I didn't write it, let me see. Our amplitude was 49. Okay, it oscillates up 49, down 49. So 49 cosine. Our b value was 2 pi over 30. T minus 15. Okay, that takes care of the vertical shift. Our horizontal shift. And then plus our vertical shift, which k was 50. Okay, so this is what our function should have looked like. This was probably one of the most complicated ones. This was really just a challenge problem to see if you could handle these types of, if you could grasp all the different parts that come together to make this. This is definitely one we're going to go over in class here. Okay, so this is everything, takes care of everything, and we could graph it on Desmos, and it would look exactly like we need it to. All right, number 15. Sketch a graph of the function and determine the amplitude, maximum displacement, y-intercept, period, and frequency. Okay. So our amplitude is 6. This also has a vertical shift up by 1. The period, 2 pi over b, so 2 pi over 1/2, which is 4 pi. And it's a cosine, which means it starts at its maximum value. Okay, so since it's been shifted up 1, the midline is now going to be at 1. So we'll say this is 1, it's our midline. Now the amplitude is 6, so it's going to be oscillating 6 above this, which is at 7, and 6 below this, which is at -5. It's going to be oscillating between these 2 points. Remember, it starts at the maximum, so up here. So 1 full period would look like this. Go down, come back up, so like this. So this is our graph. This is definitely good enough. We don't really have to label that much more. The amplitude we said is 6, so we already have all of that. The y-intercept, since it's a cosine, the y-intercept is up here at 0,7. The frequency, which we haven't done yet, is the inverse of the period. So 4 pi is the period, so 1 over 4 pi is the frequency. Or we could just do 1/2 divided by 2 pi, which is 1 over 4 pi. What do we need? And the max displacement is also 7, because that's the highest it's going to go. Maximum displacement is 7. You could also say, no, that's the minimum displacement, -5. All right, so that is it for our review here.